What's up, guys? I'm gonna do all the multi homework, but sec. So we can fix the angle of the thing. One sec, let me be right back. Okay, cool. Yeah, cool. Alright, this might be marginally better. Let me just change the window settings so you guys can see the window. Let me zoom in on the questions. Okay, cool. Okay. Let me keep this here. Okay, cool. Alright, let me just Alright, cool. Okay, let's do the first problem. First problem number 19. So, okay, so, exercise 1935 domain range of function. So, pretty easy. So, 19. The angles like sucks, but I need something like equal height. I just don't have something that tall. Okay, number 19, right? So find the domain range of the function. Just take, okay, it's pretty simple. It's just all real numbers, so. I mean, y is part of real numbers. Pretty simple. Chill. Okay, cool. Number 23, okay. Find the domain and range of the function, right? Okay, so the function 23 is just going to be z equals x plus y over xy. So basically, x is part of real numbers, y is part of real numbers, such that x is not equal to 0, y is not equal to 0, and yeah. Pretty simple. Okay, question 29. We should probably have the textbook open so I can check, but I guess I'll do that when I finish the homework. Okay, question 29. domain of this? Well, we know that basically this has to be greater than 0. So ln of 0 is undefined, so this has to be greater than 0. 4 minus x minus y. So, yo, am I doing this wrong, bro? What do I do? We kind of got, okay. Yeah, pretty simple. I mean, pretty nice, pretty simple. It just has to be greater than 0. So that means that x plus y has to be equal to less than 4. Cool. My marker's dying, bro. Okay, which one? 33. Let's actually scroll. Okay, sketch the surface given by this function, bro. Okay, 33. Wait, okay, so it's multivariable, so there's at least guaranteed to be 3 axes, x, y, and z, where z equals f of x comma y. Wait, z equals 4, right? Wait. It's just all the values x of y. So it's not just a plane centered at 4. Wait, actually, I need to check this one. Where's it? Textbook answer key. Chapter 13. Okay. 13 question 33. Yeah, it's just a plane. So yeah, this, but it extends like much more. Extends in all 3 directions. A bunch. Right. Yep. My audio down? Okay. Let's go back to the questions, bro. Okay. That's pretty easy. Okay, just go. 33, 41. 41. Use a cast system to graph. Yeah. Okay. I'll just put 41 and 40. I will do it later. Okay, 45. Match the graph of the surface with one of the contour maps. So the function is here. Duh. Oh wait, easy as we see. It just has to be C. Only option that even makes remotely close sense. So 47. You just look at it, you see the contour map. So as x, y changes, there should be a lot of values at 2 major points, which is here and here. So it should look something like. Wait. Saying planes of. I think it's D actually. Because 48 should be A. 46 should be D. Okay, so it has to be B. Oh, that makes sense because it's looking like this. Yeah. Okay, 78. Might run out of space on this graph thing. Let's go. Oh, okay. Let's just. Okay, alright, cool. Let's do this 78. Electric potential, any point of this. Sketch the equipotential curve. Is it not just rings, bro? Is it not just rings at those various values? Might be wrong about that. But is it not just rings around those various values? I think so. Answer key. Yeah, why say we let's do 78, bro? There's no answer key. Oops. Yeah, I think it's just rings. Use a Cobb-Douglas production function. Okay, so it gives us the Cobb-Douglas function. C equals CXA y1 minus A. Assume A is some constant. Obviously, if you double 2, it'll double this. So you double 2y. So just say C is directly proportional. How do you get that? Oh. Just say here's directly well is say is proportional to x and y. Okay, I should probably take a quick look at this because I'm gonna probably erase the rest to do this one. One no. Okay, I need to take a picture of this real quick. Right, cool. All right, cool. Yeah, let's erase the stuff. Let's do question 79 and 81. We already did 79, so let's just do 81. PV equals KT. Okay, this is too easy. Wait, this just feels so weird. Okay, so PV equals KT. Actually, we don't need 79, so just need 81. So PV equals KT. And we're supposed to, the tank contains 200 cubic inches of nitrogen. So 26, at a pressure of 26 pounds per square inch, a temperature of 300 K. So K is going to be 26 times 2,000 divided by 300. 26 times 20 divided by 3. Cool. That's pretty easy. 81 part B. Alright, I'm gonna have to use a red marker, assuming that's ugly. Okay, 81 part B. Right, P is a function of V and T. So P equals to KT over V. So P is a function of V and T, and describe the level curves. Honestly, what is a level curve, bro? Even is a level curve. What is a level curve? Oh, okay. Cool. Well, you could just graph it. I mean, it's pretty simple. It's literally just graph. Not really much to say there, but TBH. Cool. Yeah. Okay, cool. We're done with 13.1. Oh, I shouldn't have erased this. That's fine. It's fine. Just go with 13.2. Yeah. Lessons. Let me just write down the homework questions. So, what? There's no questions. It's like 3 questions. Okay, cool. 1, 15, 27, 43. Yo, this actually brings me back, though. I used to do this all the time, right? I used to do like a bunch of these types of videos all the time. Literally, it used to be like pretty prominent in things people associate with me. Okay, cool. Fortunately, to scroll through these problems until we get to the actual problems. Figure it out. Okay, cool. Number 1. Wait, how do we verify the limit? I low-key forgot. Yeah, I should get a chair here, bro. It's getting kind of comfortable. Just 1 sec. Okay, cool. Now standing feels much better. Question 1. So, okay, we need to use the definition. So we go back. We go back to the definition of a limit. So to do that, you need to let f of x, y equals x, and L equals a. Yo, I still don't get this. Like, when does this not work? I want to see an example where they try to verify the limit and it just doesn't work. Because it feels like you could do this for anything, but okay. So we just need to say f of x, y minus L is equal to x minus a, which is less than epsilon. I need to go back So it follows that I'm so confused. What is this even doing, bro? Okay, cool. Apparently this works. Why? I have little to no idea, actually, but okay, let's go to question 15. Discuss. So lim x comma y is going to be equal of the approaches 0 comma no 1 comma 1 of basically xy over x squared plus y squared. It's going to be equal to following. So let's just try direct substitutions. That just makes it 1 over 2. So okay, let's actually check the answer key for the last one. So 13.2. Proofs? Okay, it doesn't show. 1 over 2 continues except that. Oh yeah, of course. 0, 0 stuff, except for continuity because the limit doesn't exist at that point. So therefore it cannot be continuous. No, why does it keep scrolling me all the way up? I don't like. Okay, cool. 15, let's do 27. Really small at the bottom. Yeah, this is the problem. So the limit as x approaches, x comma y approaches 0 comma 0 is what you're looking for. And it's equal to of x minus y over square root of x minus the square root of y. I think it just does not exist at that point. Because obviously it's going to be 0, but something over 0. Yeah, it does not exist. That was too easy, so let's just do another one. 43. Okay, so this limit, it obviously just does not exist. Let's discuss the continuity of the composite function, f of g. Well, g is going to be always continuous, right? So let me do f of g of x of g of, wait, how do you composite functions in multi? Wait. Oh, okay. Yeah, I think you can. So it's just going to be f of x comma y, because you can't normally composite multivariable functions, but you can because one is not multivariable. 1 over 2x minus 3y. And it's pretty simple from here. You just say 2x cannot equal 3y. that x cannot equal 3 over 2y. For the final statement, and let's just be 63 really quick in the corner. Find each limit. Ugh. You find the xy's limit and the yy's limit for these 63, right? So it's basically as if you're finding this derivative is going to be equivalent to the partial with respect to x and the partial with respect to y. So let's just take the partial, right? That feels like the easiest way to do it and the simplest way to do it. So let's do it that way. Let's just take the partial. So f of xy equals x squared minus 4y. So the partial with respect to x is going to be equal to 2x. And the partial with respect to y is going to be negative 4. So that should be the value of those limits. That's the right section. Yeah, 2x and negative 4, that's right. All right, cool. So we're done with 13.2. Let me just take a picture of this. Upload that on OneNote. And we move to the next question. Okay, let me just insert from the library. Okay, cool. We're done with 13.2. We move on. There's like a faint red sheen to my whiteboard now, which I will get rid of later. One sec, let me BRB. I just need to get my charger. Okay, cool. So 13.3. Go to lessons. Okay, so the current units are in there, so it's a lot easier now. $43.61, 63.83, 89.115. Okay, cool. Problem 9. Shoot. Find both first partial derivatives. Okay, easy. Now it's easy. So f of x y equals x squared y cubed semicolon the partial with respect to x is going to be 2xy cubed the partial with respect to y is going to be equal to x squared multiplied by 3y squared. Cool. Let's go to the next one. 11. Z equals x squared root y. If z equals x square root y, then d z dx is going to be square root y, while dz with respect to, it actually isn't a d, it's delta, not delta. It's, what is it called? What is it called? I don't even know. For some reason, I always call it d even when it isn't. Okay. dz dx dz dy. So let's imagine if the x is a constant, so it's just going to be 1/2 y to the negative 1/2. Okay, let's do number 13. Okay, z equals x squared minus 4xy plus 3 squared. So z equals x squared minus 4xy plus 3y squared. Dz by dx is equal to 2x minus 4y, whereas dz by dy is going to be equal to vector y, so it's going to be just minus 4x plus 6y, 25. H of xy is going to be equal to e to the negative x squared plus y squared. Okay, this is ugly, but okay, dh by dx going to be very ugly, but it's just going to be e to the negative x squared plus y squared multiplied by negative 1, negative 2x. dh at dy is going to be just the same thing, but instead this time it's just going to be with respect to y. So that means there's going to be y variables instead. All right, cool. 43. Evaluate f sub x and f sub y at the given point. Let's go. F sub x is going to be equal to, right, yeah. E to the y multiplied by cosine of x. F sub y is going to be equal to sine of x times e to the y times sine of x. It's just a function. So plug in x equals pi over 4, and x equals pi, xy equals pi comma 0, xy equals pi comma 0. Right? Yeah. Okay, cool. So the x value is going to be pi. So cosine of pi is going to be 0. So it's just 0. Partial with respect to x. Cosine of sine of pi. Sorry, cosine of pi is negative 1. So it's just negative 1. So that's just negative 1. E to the y is just going to be 1. Sine of pi is going to be 0. So it's just going to be 0. Okay, cool. 43 is done. Let's go to 61. This is pretty easy. You just do the same thing. F of x comma y. Oh, you guys can't even see my face, but I gotta move this up here or something. But then it blocks the whiteboard. So, 63, 61. Yeah, 61 is pretty easy. Yeah. Same thing with 3 variables. Okay, let's start. Let's do 61. F with respect to y. Well, actually, it's just 1 over y multiplied by thing. So it's just going to be x over z multiplied by y to the power of negative 1. So negative x minus z multiplied by y to the negative 2. df by dz. It's going to be the same thing, but just y instead. So it's negative x over z multiplied by z to the negative 2. But this is y. Okay, cool. Let's do some 63. Actually, we're not that far off finishing. I'm low-key, I might stop. Okay, I'm getting a little bit lazy, but 13.3, I'm stopping after, because I'm just gonna do the rest tomorrow, because I don't, low-key, I don't feel like doing no more math, bro. Okay, z sine x plus y. Constant multiplied by cosine x plus y multiplied by, yeah, so that's it. And then obviously it's gonna be the partial for x and y is gonna be the same, except actually the exact same. So z multiplied by constant, so it's just gonna be the constant. So cosine x plus y. Cool. Let's do 63, 83. Let me scroll these. Okay, we have to do 83, 89, and 115. Your secant is secant x tan x, right? Secant y tan y. Doody doo. What we have to do here? I think it's just a part and all the partials. The mixed partial derivatives are equal. Gotta be a more efficient way to show that. Wait, graphically they have to be the same. But is there like a proof method? Proof, mixed partials. Fix A and B and define. What is mean value theorem? Yeah, what is this proof, bro? I'm not doing this. I'm just gonna say mixed partial derivative. Okay, cool. Finally, 1:15. I'm gonna be done for today, bro. I'm tired. Also, I'm just tired of multi. Okay. Temperature any point in steel plates XY. No, we're done here. I know how to do it, but it's kind of boring for tedious. All right, guys, I'm head out for today. Have a good day, and I'm gonna.